It's tough out there for a spacecraft. Hardware in space must brave an ocean of dangerous radiated particles. These particles can slowly wear on a spacecraft over time, hit once and cause a temporary problem, or short the system in a single blow. Whether a spacecraft is heading to the moon, like the Artemis mission, or facing off with the sun, like Parker's solar probe, everything on board must be checked for reliability before launch.
Every part has to be tested, and that's where our group comes in. We take the models and we figure out what the radiation environment looks like, and then we test based on that environment and figure out whether the part will survive or not.
To improve our spacecraft and protect our hardware as it travels through space, NASA has the Space Environment Testbed Mission, or SET.
This is a mission where the whole point is radiation.
SET helps researchers to better understand and design for the potential radiation effects that await spacecraft.
It's actually doing measurements of the radiation environment. Some measurements are actually counting individual particles as they come in, and other measurements are actually taking account of what the cumulative effect of all these particles are.
All of space is a radiation environment, but the exact conditions will vary by destination. The Sun fires protons. Earth harbors swarms of protons and electrons. Jupiter does the same, but in greater concentration and at higher energy. And everywhere you go, there are heavier ions from galactic cosmic rays. No spacecraft passes through unaffected. More knowledge from SET means more efficient spacecraft designs. For example, less shielding may be necessary.
Right now we assume that all missions are going to have a shielding thickness, and so by shielding thickness we mean how thick are the walls of the spacecraft or the instrument. And we assume they're going to be about 1/10 of an inch.
You can think of active shielding. You can think of electrostatic shielding. I mean, some kind of electrostatic spheres that protect us.
If we can get better models and we can more tightly refine what the radiation environment looks like, we can maybe thin those walls out.
Lighter, thinner spacecraft can create savings in cost and room on board.
One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft. Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
Shielding, passive shielding, can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shielding, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now? Okay, maybe I can make a magnetic field, you know?
We always need to improve our designs of spacecraft because it will give us, it will help us improve our instrumentation, make them less expensive to design, and give us more accurate measurements.
We also expect there to be applications to help protect the hardware that will bring people to the moon and beyond.
We'll be able to ensure that humans and electronics and spacecraft and instruments, anything that we're actually sending into space will survive in the environment we're putting it in.
With SET, NASA can get ready to go farther.